Hello Bucharest. I'm so happy to be here. My best friend is Romanian. She has been telling me so many amazing things about Romania, so I'm very happy that I'm finally here. How are you feeling right now? Good? Good? Are you hungry? Because I know this is the talk just before lunch, so bear with me. I'm going to try to make this as fun as possible. Bear with me for a few minutes and you'll have your delicious food after. Who is this random girl on the stage right now? As they already really nicely presented me, my name is Claudia Hernandez. I am a Mexican developer currently working in Paris in this company called Dailymotion. Dailymotion is just a video sharing website. And if you have any comments, complaints, questions, you can find me on Twitter as Coste4, or if you're more of an email person, you can find me on claudia.hernandez@dailymotion.com. But enough about me, because you didn't came here to talk with me or to see me. You came here because you like JavaScript. And as I told you, this talk is supposed to be fun for you, and you are supposed to learn really cool and weird things that's going on in JavaScript. So for the following minutes, I'm actually going to be your own personal white rabbit, because I'm going to drag you with me into the rabbit hole, and we're going to go into JavaScript Wonderland, all right? So hold on. Now, I'm not an expert, okay, but I'm a really curious person. I really love knowing why things work a certain way or not. So, as I told you before, this talk is just a collection of JavaScript oddities and weird things going on that I hope that is going to help you become better developers and just try to understand a little bit more what JavaScript is all about. So this talk is just vanilla JavaScript, all right? No frameworks, nothing, just plain vanilla JavaScript. And with that being said, you know, JavaScript is a kind of language where nothing is what it is. Because you have things like mathmin is not less than mathmax. What? Because actually mathmax is equal to minus infinity, and mathmin is equal to infinity for some weird reason. Then you have two equal-looking arrays that are supposed to be the same, but actually they're not, right? What's going on? And then you have things like this. 0.1 plus 0.2 is not 0.3 in JavaScript world. It's just apparently something else. So what have I just shown you? Like, what's going on, JavaScript? So I'm not going to tell you the details of the previous examples. So that is your homework. But if you want some clues as to why is JavaScript behaving that way, one clue is that it has to do with inconsistencies with floating point numbers. And this is the floating point standard, which is not just something about JavaScript. It's a standard that is used in other languages as well. And for the array example, you have to know the difference between primitive and reference types in JavaScript. Now, with that being said, this is the first part of our journey through Wonderland. And our first stop is our beloved nan. So we all know that nan actually stands for not a number. However, type of nan is actually number. So it's like, it never makes a lot of sense. And nan in very simplistic terms is just the return value of a failed mathematical operation. So what if we try to do an operation without both operands being numbers? You will get nan. If you try to do an operations or numbers that are not defined, you will also get nan. What if we try getting the negative square root of a number? We will also get nan. So basically what nan is telling us is like, hey, I tried to perform this mathematical operation, but I failed. So here's this failed value instead. And I think the problem with nan is that maybe the label nan is a little bit misleading. Maybe it will be way easier to think of it as failed number or a bad number or invalid number more than not a number. Because the bottom line is that nan is still a value of numeric type, but it represents a value that could not represent a valid number. Now, mathematical operations in JavaScript cannot lead to an error or crash. They will just use nan. It's just like JavaScript way of washing its hands. It's like, I don't know how to do this thing, just get nan, and that's it. So how can we know if a value is equal to nan or not? And if this was your first guess, let me tell you something. Now, nan is not equal to, greater than, or less than anything, including itself. And at this point, you're probably thinking like, yeah, but why is that? Now, none is not just a JavaScript thing, as I keep saying, just like floating point numbers. None is actually defined by this IEEE 754 floating point standard that, to keep things short, basically this standard says that there are 60,777,214 different floating point values as none. What does this mean in easier words? It means that there are so many different kind of nones that it's highly improbable that one none is going to be equal to another none. So, yes, indeed, none is not equal to another none. And I think this is the proper timing to actually show this. None actually stands for not a number. And if you actually want to know if a value is equal to none or not, you can use JavaScript built-in function is none. But enough about none. Let's talk about sorting now, because we all love sorting, right? We do it every day. We sort our sock, we sort numbers in a telephone book, we use it every day. So now we have this really nice looking array, 33, 2, 98, 25, and 4. And we, of course, call the JavaScript sort function, and then you end up with 25, 33, 4, 98. It's like, I don't know about you, but normally 25 and 33 comes after the number 4, no? Or at least in my world, I don't know about you. What's actually going on with JavaScript? Why is it giving us this really weird answer? So what's actually happening here is lexicographical sorting, which is dictionary-like, telephone book-like kind of sorting. So just in an easier sense, it's just alphabetical sorting. And what's actually happening is that JavaScript will transform all of the numbers in the array into strings, and then it will compare those strings according to their Unicode code point value. So what is this code point value that I'm talking about? Basically, it's just the ID of any Unicode character. Now, in this example, we have a colors array, really easy. We have red and blue. We call the sort function, and we have blue coming before red, right? Because B comes before R, like nothing weird over there. But now you have a numbers array with 80 and 9, and you call the sort function, and 80 is still coming before 9. So why is that? This is the exact same thing as if you call that numeric array with those numbers as strings. So, as I was telling you before, the Unicode code point value of 80 is actually less than 9. So that's why 80 is coming before. So in a sense, 80 is just lexicographically less than 9. So, I mean, that's okay. It starts to make a little bit more of sense. And actually, if you want to know the code point value of any character in JavaScript, you can use the built-in function code point add. And now that you know the mystery that actually JavaScript is just transforming everything into Unicode code point values and comparing those, you can actually do something like this as well. Because emojis also have Unicode code point values. And in the second array, you have numbers, you have emojis, you have string numbers as well, and for JavaScript, it's just the same. Everything is translated into strings and compared according to Unicode code point values. And now, if we go back to our previous example, the first one, it starts to make a little bit more of sense, right? JavaScript is not as crazy as we think it is. So 25 and 33 are indeed lexicographically less than 4. So JavaScript is doing a good job. But I guess when we're trying to sort numbers, lexicographical sorting is not what we think, right? Like, this is not what we want to do with our numbers. So what are we missing here? And I think you have probably used it before. What we're missing is a compare function. So the sort function can take as a parameter a compare function. And given this compare function, given a and b, if a is smaller than b, you will return -1, and the a element will come before b. If a is greater than b, you will return 1, and b will come before a. And if a and b are the same, you will return 0, and the elements will remain unchanged. So finally, what you can do is you can give the compare function to the sort function, and you can finally achieve a numerical sorting. To be honest, this is like too much work just to achieve a numerical sorting, but that's just how JavaScript works. And the tilde operator, how many of you knew that this was called the tilde operator? All right, a few of you. And how many of you have actually used it on your daily applications? Okay, not so many. So yeah, the tilde operator, it is actually a bitwise operator. And what's that? So a bitwise operator is just an operator that will take a number, an operator, and then it will do some kind of operation on it, and it will transform it into a sequence of 32 bits, do the operation, and then it will return back the result as an integer. This is really important, the integer part. So maybe you're more familiar with the bitwise and the bitwise OR, and they are not the same thing as a logical AND or the logical OR. But actually, there are 7 different kinds of bitwise operators in JavaScript. I'm not very sure a lot of people use them commonly because they are very B2B specific operators. But today, I'm going to show you some cool hacks that you can do with the Bitwise Not. So first of all, what is the Bitwise Not? Basically, as I told you, it will transform a number into a sequence of bits, and then it will invert all of those bits, right? Because it's a not. So I mean, I know that normally we don't have to deal with this kind of bit-to-bit operations in our daily applications, because that's just not that common. So let me show you the Bitwise Not in a more approachable way. Basically, the Bitwise Not is just doing this small algorithm. It's just adding a +1 and changing the sign. So if you give a -2, it will return back a 1. If you give it a -1, it will return a 0. If you give it a 0, it will return a -1, etc., etc., etc. Now, the golden question here is, the $1,000,000 question is, what actual practical use can we give to this small operator? And just one really cool hack is, if you use a double bitwise operator, you can actually truncate numbers. You can eliminate all of the decimals out of a number, and this is actually faster than using math_sale or math_floor. Actually, you could use other bitwise operators to achieve the same thing. And as I told you, this is faster than math_floor. But let's keep talking about the Bitwise Not. Another cool hack that you can do with it is, imagine you have a list of invitees for the tea party, okay? Because this is an Alice in Wonderland theme conf, so of course we have the Mad Hatter, Mad Shirt, whatever. So there is this function for arrays called index_of. So index_of will basically return back the position of an element if it was found on an array, and if it wasn't found, it would just return a -1. Now, a lot of developers will use this function to tell if the element is found or not, and it will just compare against different than -1, equal to -1, greater than 0, less than 0, etc. But with the Bitwise Not, you can actually do a pretty cool hack. And in this case, if the index_of returns a -1, which means that the element was not found, the tilde operator will just transform that -1 into a falsy 0, meaning that the element was not found. And in any other case, it will produce a truthy value, and it will mean that the element was found in that array. Now, before people start making like angry faces at me and like start getting angry at me, yes, I know that this is not very like human readable, and I wouldn't recommend showing this to your developers because they will get very confused if they actually don't understand how this works. But the good news is that for ES6, there is actually this new, shiny, amazing, cool function called includes. And basically, it's doing the same thing. It will return a Boolean saying if the element was found or not in the array. So that's a really cool feature to look for in ES6. And for loops. I know for loops doesn't sound that exciting, but I mean, just bear with me a little bit. I once saw this for loop in a book, and I was just like, what's going on? Like, I don't understand what this for loop is doing. And of course, I had to check what it does. And I'm going to remind you something very basic about for loops. So for loops, as we all know, have 3 parts. They have an initialization part, they have a condition part, and they have an iteration part, right? We have been doing this for years. What I didn't know is that all of these parts are optional. You can just skip them if you want. You can skip the first part because you can declare variables outside the for loop and it's fine. You can skip the second part, and if you do that, the condition part for JavaScript will automatically be considered as true, and then it's up to you to break the for loop whenever you want. Or you can even skip the third part. And in this particular example, the condition part is acting as the iteration part at the same time. And once this variable I drops until 0, it will return a falsy value, and then it will go out of the for loop. And as I told you, you can also just skip everything. And this is, as I told you before, the condition part is going to be considered as true, and this is just a while true, and this is just an infinite loop, right? So mystery solved. And I promise this is the last part of the first part. So let's talk really fast about undefined. Now, undefined. We all know that undefined is a variable that has been declared, but at the moment hold no value on it. So this piece of code shouldn't be shocking to anybody, right? Like, this is a normal thing. But actually, undefined is part of the global object. It's part of window. What will happen if we actually wanted to redefine undefined? And the cool thing is that this was actually possible, but a few years ago. So for older browsers, you were actually capable of redefining undefined. Imagine all of the errors and things that you will do to your developers if you did that. But the good things and the good news is that modern browsers, of course, already fixed this bug. Now, I understand that while it's becoming less and less of a problem, if you have to give support to older browsers, you have to pay attention to these kind of details because, you know, it's our responsibility as JavaScript developers to know this kind of stuff. And the thing is that JavaScript is rarely run in isolation. We often run JavaScript with external libraries, with code from other people, so just pay attention to these kind of details. But that's not all. Actually, undefined is not a reserved word in JavaScript, meaning that you can also use it as a variable name, which I wouldn't recommend because it would just freak out a lot of people, and it's really weird. Just don't do it, please. What have we learned so far in these few minutes? Not a number is a number. The Array.sort sorts lexicographically. The tilde operator is the Bitwise Not operator. All parts in a for loop are optional, and undefined can be defined. Sometimes. Am I boring you? Like, is this like I already knew all of this thing? Like, just go home? No, it's good. Okay, wait a minute. Because the cool mad JavaScript party is just about to begin. And first of all, a disclaimer. The following content is designed to challenge and amuse programmers, not made to be suitable for practical use. So you have been warned, all right? How many of you have seen code like this before? Right? I see some people laughing. Because, you know, this is the kind of code snippet that we love sharing around to make fun of JavaScript, to say how silly and stupid JavaScript can be sometimes. And you are right. But you know, the following slide has one of the JavaScript jokes that I love the most. So what is a minion's favorite JavaScript expression? And the answer over there, that is actually a valid JavaScript expression. Do you have any idea what it could be, what it could mean? Yeah, but name A. So that's actually a valid JavaScript expression. Crazy. So with that being said, let's talk about non-alphanumerical JavaScript, which is JavaScript without letters and without numbers, just like the examples that I just showed you. But first, a very, very important thing about JavaScript that you have to remind yourselves. JavaScript is an untyped language. It means that we don't have to declare the type of data that a variable is going to hold when we're declaring it. We don't have to tell JavaScript if it's a string variable, a number variable, Boolean variable, etc., because that's the job of the JavaScript interpreter. Now, the problem is when we actually mix types in our code, because that can lead to really weird, crazy results. And I know after lunch there is going to be a really, really awesome talk about typing and flow, so I'm really looking forward to that talk. And what I'm going to be showing you next now is how to write valid JavaScript using square brackets to access arrays, strings, and object properties, parentheses to call functions and avoid errors, curly brackets to get the string object, the plus operator to append strings, add up numbers, and cast things to numbers, and the exclamation point to cast things to Boolean. So I'm not crazy. This actually works. You can actually write JavaScript this way, and you'll just see how it works. And before I start actually talking about the basics of this non-alphanumerical nonsense, let me remind you again something about JavaScript. Everything in JavaScript has a Boolean value. Everything can either be falsy or truthy. How can we know if something is falsy or truthy in JavaScript? Here is the golden rule. Everything in JavaScript is truthy unless it's falsy, right? But it's true. The falsy values by default are false, 0, an empty string, null, undefined, and none. And truthy values, as I just told you, is everything else. It can be a string 0, string false, an empty array, or an empty object. Finally, we finally arrived to the basics of this. So what's going on in this example? In the first example, we're trying to negate an empty array. So we're forcing JavaScript to treat that empty array as if it was a Boolean type. Now, if you remember from the previous slide, an empty array is just a truthy value. So if we negate a truthy value, we will get false. And in the second example, we're negating a false, so we get a true. So now we have this really small base of how to create false and true just using square brackets and exclamation point. With this, we can actually create numbers as well by using the unary plus operator, which actual purpose is to convert things into numbers, to cast things into numbers, right? And now that we have 0 and 1, guess what? We can create any other number as well. And you can picture this as just adding 1 plus 1 plus 1 plus 1 until infinity, right? Because we just have a lot of time to do that. We can also get strings using this technique. And the way this works is that in this first example, the plus operator can only concatenate strings or add up numbers. If you try giving any other different type of variable to the plus operator, JavaScript will automatically convert it into either a primitive type, a number, or a string. So in this first example, the first operand is already a false, as I showed you in the previous slides. A false is a primitive type, so for JavaScript, that's okay. And then the second operand is just an empty array, so JavaScript is like, I'm going to change that into string. So in this way, we can actually concatenate the primitive type false with an empty string, and it will give us a string false, and it works the same way for a string true. Now, these work the exact same way with numbers. By just adding an empty string, we can cast things into strings. What if we wanted to make bigger numbers? Because, I mean, as I showed you before, we are not just going to add 1 plus 1 plus 1 until infinity, right? That's too much work. So actually, for bigger numbers, what we can do is we can convert into strings every single digit in the number and then concatenate those strings together and then cast the whole thing back into a number. So 123 actually looks like this in non-alphanumerical JavaScript. And it's valid. It works. You can check right away in your console, in your developer tools. So let's speed up. What if we try accessing a non-existent element in an array? We will get undefined. If we try converting an object into a number, we will get none. And if we try converting an object into a string, we will get the string object. Now that we have access to all of these words and vocabulary, and by words and vocabulary, I mean words like undefined, object, true, false, what we can actually do is we can convert those words into string, as I show you, and we can access every single character in those strings as if they were arrays. Now, if you're getting the idea out of this slide, you will realize that basically what we can do is we can create up words that actually mean something to JavaScript, such as the word filter, which is just a function of arrays, right? So Martin Kleppe, the creator of this website that is called JSCamp, basically he called this technique JavaScript Scrabble, because what we're doing is we're trying to make up words that actually mean something to JavaScript out of the set of characters available using this technique. Now, to keep things short, because I cannot talk for hours, we basically have access to functions such as call, concat, constructor, join, slice, sort, filter, etc. Now, I've been talking a lot about these things, and I've been showing you how can you display some numbers and true and false, but how can you actually make this work? How can you put it in action? So I'm going to show you this really, really small example. And basically, this piece of code is just making an alert wand in your browser, okay? And this is how it works using the non-alphanumerical approach. So this first pair of square brackets is just a normal empty array, right? So the filter part is just trying to access the filter property of that empty array, which is a function, as we know. Now, that constructor part is just trying to get the constructor of functions. And that constructor of function can actually take as a parameter a script that will return back a new function with that script as its body. And finally, as you might be guessing by now, those last parentheses are just automatically executing that new function. And therefore, this small piece of code will actually just display an other one in your browser, and the code behind it is the actual code to make it work. It does work. And it's just parentheses, square brackets, is just part of the craziness of JavaScript, right? So I know this is so weird, and it's like just part of the magic of JavaScript. And if you're actually interested in this technique, there are a lot of online converters that you can check out to play around with it. And what I would really like to recommend is to check the source code of some of the converters, because it's really interesting understanding how it actually works, behind. So there is hieroglyphy demo, there is JSFog demo, sexstar.js, JS Screwed, very nice names. And yeah, this is the most well-known JSFog. Now, when I was actually doing research for this talk, I realized that there were no limits with this technique. I came across this repo that is called jQuery Screwed, in which basically this guy, he just rewrote the whole jQuery library using non-alphanumerical JavaScript. Because, you know, some people have more time than others. And this is the source code. So yeah. And at this point, you're probably thinking like, cool, that's very cool, Claudia, but why on earth would I ever care about this nonsense? Like, we are never going to write JavaScript this way, and you are totally right. You have to be I don't know, you have to hate yourself in order to write JavaScript this way. But I don't know, I feel it's important to know the power of the language, to the extent in which JavaScript can actually go. And if this reason is not good enough for you, or if it's a little bit of a lame reason, I have another one. So this is a tweet from Martin Kleppe from a few months ago, and he was directing to a blog post from a security engineer. And basically what this security engineer realized is that it was possible to inject malicious JavaScript into the eBay website by using non-alphanumerical JavaScript. And basically what he realized is that eBay will filter HTML tags such as script and such as iframe, but apparently it was totally unaware of JavaScript being injected in a different way, such as non-alphanumerical way. So I think this has already been fixed, I hope. I'm pretty sure it's fixed. But for security reasons, as I keep saying, it's our responsibility as JavaScript developers to know that this could happen and just try to protect ourselves in the future if someone is trying to make funny business with our application, right? So yeah, JavaScript, the language that we all love to hate and hate to love. And the sad news is that this talk is coming almost to an end. But I can't live without talking about arrow functions in ES6, right? Because I just really, really like them. So I guess a lot of us have come across similar code like this, right? We have a foo function, and we're using a setTimeout function, and then we try accessing this inside the function of the setTimeout function. But we know that this doesn't work, because the this inside that function is no longer referring to the same context of the foo context. So a lot of developers have solved this issue by adding extra variables such as self equal this, that equal this, and okay, it works, but it's messy and it's confusing. Why would you be calling variables that equal this? It's just too much complexity. The good news is that arrow functions are here to save us all, because arrow functions don't have a this at all. They don't have context. They actually don't have this, arguments, super, or new target. Any reference to all of these things will just lexically resolve up to the outer scope, because JavaScript. And if you actually want to refactor or rewrite that previous example, you can just use an arrow function and it will just naturally work. But what if you are very stubborn and you actually want to hardbind something into the arrow function? In this example, even if you want to hardbind an ID 100 into the arrow function, it won't work because there is no context the binding can actually grab on. And it will still display an ID 42, which is the original of the foo context. And I guess what I actually wanted to say in this last part is just that arrow functions are not about syntax sugar. It's not about less typing. It's not a way of taking less time to write the word function. They actually have a purpose and a specific behavior that we have to understand how it works and use it properly. Now, was it all of this a dream and nonsense? Sadly, no. This is real JavaScript. It works. But why should we care? First of all, as I keep saying, knowledge is power. We have to know why we're writing the code we're writing and how it works. It's the only way we will be able to make other people learn from our code and understand our code. We have to keep pushing the limits of the language. It's up to us to push the limits of JavaScript. Right now we have JavaScript on the browser, on the server, on robots, on the desktop. It's amazing. There's so many cool things that we can do with JavaScript, and it's up to us to keep pushing those limits. We have to break rules. And playing is learning. For me, it's this quirkiness of JavaScript, the fact that you can make a lot of mistakes with it and that it's so weird and funny. It's what drives me to make projects, to make demos, to try testing all of the frameworks out there. It's just part of the cool thing that makes JavaScript as a whole. And as I keep saying, it's all about the power of the language. You can write JavaScript only using symbols. You can run JavaScript on the server. You can do a lot of things with it. So there is a quote that I really like that says, JavaScript is a language that survived not because of its flaws, but because of them. And last but not least, this is a quote from a book that I really enjoy reading, and I really recommend that you check it out. It's If Hemingway Wrote JavaScript by Angus Kroll. And it says, the best JavaScript developers are those who obsess about language, who explore and play with it every day, and in doing so, develop their own idioms and their own voice. Angus Kroll, check it out, it's really cool. And mulțumesc, I hope you liked it, and let's have lunch.
Whoa, my brain hurts now. The people who tweeted some questions, I'm not going to ask them of Claudia now because they're kind of a bit ambushy. Like, can you write your name using that technique, using the console on stage?
I can use a converter.
So I'm not going to ambush you with those questions. Are there any questions from the floor? Cool, so everybody understood everything immediately. Excellent. We're running a little bit ahead of schedule, which is good because it gives us extra time for lunch and more time for you to approach our speakers and ask some questions that you didn't want to ask publicly. So, ladies and gentlemen, give it up for Claudia Hernandez.